Hello everyone. This is Rasheed Kibria from University of Florida. Today I want to talk about my developed FSMx-Ultra tool. The main purpose of this tool is to automatically extract all control FSMs from a gate level netlist. The gate level netlist can be either hierarchical or flattened. There are basically two versions of FSMx-Ultra tool. One is called FSMx-Ultra FN, that stands for analysis of a flattened gate level netlist. The other one is FSMx Ultra Asian, that is for hierarchical netlists. In this demo, I will show you how you can run this FSMx Ultra tool in our Ace Cloud. Implementing this tool and testing the executables in Ace Cloud was quite challenging. So I have finally been able to do that, and I have already uploaded those tools in my Ace Cloud. You can, uh, the first thing you have to do, you have to put all the three tool executables in a single folder. Here you see I have created FSMx underscore ultra underscore FN, this main folder, and there I have put all the three executables. And here from the command terminal, I will first move to this directory, and then I will see what are the contents here, and we see here UI. UI stands for the standalone graphical user interface for FSMx Ultra, and you can execute that by just writing /UI. And if you do that, it will open up a graphical user interface for you automatically. And here you see it is asking you to provide some inputs. The first input you have to provide is the technology library that was used during the synthesis process. In this demo, I will be analyzing the flattened gate level netlist of the UART core from ARM. And I have also used one of their provided technology library, that is Global Foundries 14 nanometer technology. I have used that to synthesize all the RTL designs, and I have got a synthesized netlist which contains around more than 5,000 gates, and also so many interconnections between them. So it is really a medium-sized graph to be netlist graph to be analyzed. I will first browse through and go inside this ARM file, and here I will see GF14 nanometer, and inside library, I will see here the technology library in .lib format, which was used during synthesis. In synthesis, we normally use .db files if we use Synopsys's design compiler for synthesis purpose, and I have actually used design compiler to synthesize this netlist. So I will first add this technology library file. Next, I will add the technology library file in .b format. ARM has also provided us the ATPG compatible technology library in .b format, and I have already copied that from their from the parent directory. And here you can see such ATPG compatible technology library in .b format, and I will hit open. It will add that. Now I have to read the flattened gate level netlist, and you can find that inside inputs folder. Here you see UART underscore fn.v. It is the flattened gate level netlist of the UART core from ARM. And if I click on open, it will add that the last input we have to provide is all the FSM extraction reports generated by RTL FSMx, and I can do that via simply browsing. And here we'll see two FSM extraction results. We need to include all of them. One is for the receiver FSM of the UART core, and the other one is for the transmitter port. And if I hit open, it will add that. Finally, I will click on configure FSMx Ultra button. If you do that, it will generate a shell script for you automatically to run these two tools automatically. So inside this shell script, you can find the shell the commands to run these two software executables. And here it is simply running one executable at a time, running synopsises, test max for ATPG-based analysis to extract the state transition graph of the identified control FSMs. And finally, it is using the state transition graph extractor tool to generate the the gate level STGs. So I will again go to the user interface, and I will hit on extract control FSMs button. And if I do that, it will start running the tool. And here in this parent directory where all the tools are located, if you reload that, you will see here some files are coming up, and these two files are generated when the netlist graph is being constructed. And in the connected components report, we can find all the information about the graph. And after 1 or 2 minutes, the FSM extraction process will begin. And here you see it is really a massive graph, and there are so many edges here. I can clearly see there are total over 12,395 edges. So it is really a massive graph, and also 5,000 plus gates. The graph is complex, and here you see the process has been already finished. It really doesn't take that much time, like only 1 minute to 2 minutes to extract all the control FSMs. FSMx-Ultra is better in terms of runtime, performance, scalability, and general usage compared to my previously developed FSMx tool. FSMx has a lot of scalability issues, but FSMx-Ultra is free from all of them because it can extract control FSMs from any FSM from FSMs with any sort of state encoding, like one-hot encoding, where you may have so many states. Like I have seen memory controller IP from open codes that had 66-bit wide state register. So, and it was one-hot encoded. FSMx was not able to extract control FSMs from that, but FSMx-Ultra did. And here, as the processing has been finished, if I uh, click reload this folder, I will see a folder, a report directory that is something underscore report in this format. The first part UAT underscore FN, this name comes from the flattened gate level netlist which was being analyzed. And inside this report folder, you can find 3 subfolders. In the first subfolder, in netlist directory, you will find all the extracted control FSMs from the netlist along with their state transition logic. So FSM1, this is the first extracted control FSM, and this one is the second. FSM combo1 is the state transition logic for the first control FSM, and this one is the state transition logic of the second control FSM. So I will now show you one file. So yeah, if I click on it, and it will show us the extracted state, the extracted FSM minimum extraction region of the control FSM. And from this file, we can actually have some sort of idea of which FSM is this. And if we look into this name, it will be clear to us that it is the receiver FSM of the UART module. And this extracted control FSM is pretty big, and it has so many gates and a state transition logic that is composed of basically all the gates except the flip-flops. The flip-flops actually form the state register of this FSM, and this one is actually represents the FSM for the receiver module. And in the second module, in the second extracted control FSM, here it is the FSM of the transmitter. of the UF module. And the same logic here, that is the state transition logic along with the state register, which forms the FSM minimum extraction region, has been generated by my FSMx-Ultra tool. And this one is the pure combinational state transition logic for the first control FSM. And this one is the for the second control FSM, the state transition logic. Inside statistics directory, we will find a file which we can open, and I will provide you an idea of what this file stands for. In this file, if you look into one line, the first line is the name of the register. The second one is the width of the register. The third one is the FSM probability metric. The fourth field is the number of extracted gates. And here, after that, it is showing all the extracted gates along with the flip-flops and the state transition logic. Now, all of these are actually the registers which were being analyzed by FSMx-Ultra tool. And if you look at the first register, it has the FSM probability metric of only 33%, which is which does not represent an FSM at all. But if you look into the RX control state register, it has an FSM probability metric of 100%. And as I have already showed you, this state transition logic or control FSM is really very big, and it has total 46 gates, including the state flip-flops, and the state register size is 3. So the rest of the 43 gates are parts of the associated state transition logic for this control FSM. And you will also see some of the other FSM like structures. For example, this counter bit period count, it is a counter register, and it is also showing 100% FSM probability metric, because sometimes any sort of FSM may have almost 100%, or exactly 100% FSM probability metric. So it is really very hard to isolate these counters. But FSMx-Ultra has been able to segregate that and only extract only the two control FSMs that were present in the RTL design. So really FSMx-Ultra is so accurate, it can discard all the counters and extract only the control FSMs part of it. And inside STG report folder, we'll see all the state transition graphs in text format. For some library issues with HCloud, I couldn't extract the state transition graph in graphical format, but I believe the state transition, the state transition graph in a textual format is enough, more than enough to provide you insight about the gate level STG. So if we look into one file, this is corresponds to the STG, the gate level STG of the receiver side FSM. That was the first FSM, FSM_1. And if you look here, we have 3-bit state register that I have already shown you. And it is actually showing us that this file, it has total 33 state transitions. This file is kind of a deprecated file. It is only showing you only the states and state transitions. But there is another version of this file which is also generated automatically. It contains more verbosity, and that is this file. And so if you open it, it will show you the state transition graph with a more detailed view. And now I will try to explain what one line actually stands for. If we look into line number 5, here a certain state transition is being happened from the state 111 to 011. And this state transition has happened for 2 conditions, and these 2 state transition conditions are mentioned here. The second one is this one, and the first one is this one. And I have counted this. There are total 17 bits here. So if you apply this input to the state transition logic, which has 17 primary inputs, then you will be able to find this state transition. So this information is very helpful for watermarking, logic locking, and other stuff. and also for security evaluation. And here, the same thing is also denoted. I have my tool also provides the another report, and it is also showing you from where to where such transitions has happened. And if you look here into this file, if I try to scroll it, yeah. So this one was the from state all the wires, and then the destination state for all the wires. And after that, this one is the name of the wires that are basically the primary inputs for all the state transition logic for this control FSM. And all of these are basically just the wires. So my tool has also extracted all the primary inputs of the state transition logic of the control FSM, which is really it was very hard to do, but FSMx-Ultra can do that. So that is all about basically the state transition graph of anything. So there are two control FSMs. So we have also two gate level STGs. The requirements are met perfectly. That was a quick demonstration for FSMx-Ultra. Thanks for hearing.